Sony Trinitron KV2141, 1977 model year, remote set, supposedly no high voltage, it's dead. This is going to kind of be a hopefully a quick fix, which Sony Trinitrons with high voltage are rarely a quick fix. In fact, they've been some of the most time-consuming sets I've ever worked on, these SCR horizontal output driven sets. But we're going to give it a shot because I need to keep moving on because the Lumasponder is in control. Now, they consider this beast a portable color TV set. Well, maybe if you're a bodybuilder, definitely not a housewife. 1.9 watts is the draw. We're going to push the power button. I heard a click. So, interesting, it looked like we had maybe degaussing or a filter capacitor charge up there. You notice it's not doing it now. But yeah, we're definitely getting a relay engage. So let's get the back off and see what's going on. Well, unlike a lot of these that I work on, this one looks like it's really got some hours on it. It's very dirty. Wonder if the picture bulb is any good. Wonder if we should even worry about that. It's actually kind of late in the day for me to start a repair video. Usually I do these well, as I always say in these videos, you always want to start with a good, thorough visual inspection. Wonder where the core went. Did somebody... That's half of the core, right? Sometimes you look at something and you just want to go, what the heck? Okay, well, I see the other half of the core down there, and I see the bolt. See the bolt right there? Right there. Of course, it's going to blow the camera out, but the bolt is laying... can I get to it with my hand? Right here. The struggle is real. Well, that would definitely change the resonance of the flyback, but how the... It's like the U-bolt broke. Because of course this goes like, you know, in here. So this is very fascinating to me. Obviously this bolt failed and the transformer fell apart. Why? Was the bolt just under too much tension? And I mean, you could see it snapped like glass. Is it a metallurgy problem? Now, I don't think winding a coil around it that direction, it's at the null of the magnetic field, right? If you wind it this way around the core, then it becomes, you know, it'll develop voltage. But if you wind it this way, it doesn't. So can I just take and put a piece of wire around that? Usually there's little round circular pieces of paper that isolate the two sides of the core, and you can see those are gone from here. So I need to, okay, I just put some tape on this. You know what, I got transformer tape. Maybe I should use that. Okay, this is actual like insulating transformer winding tape. And I think the point of this is just to keep it from making noise, the core. But I'm going to put it there anyway. I just put a piece of wire around it, a piece of heavy galvanized wire. I wonder if this aluminum acted as a heat sink. Wonder if that's why they had that bolted down so hard. I don't think I'm going to worry about that. This TV won't be used for if the CRT is even any good. Anyways, I was saying when I saw that, it's a little bit late in the day to be starting on a TV, so it's going to be a little dark. I might be using a flashlight a lot. I used to work on TVs when I was a teenager. I used to work on them till 2 in the morning, but I kind of gave that up. But I got a nap in today, so we might take this one deep into the night. Okay, so the question is, what was damaged by that being like that? Assuming that it was working when that failed. Such a strange failure. Okay, we're going to go through and check a bunch of stuff with the capacitor wizard, and this is great for these type of things because it's testing with, like, I think it's 5 millivolts of 100 kilohertz signal, so we can check for shorts and stuff without turning any semiconductors on or without any resistors really interfering unless they're super low resistors. So I'm going to check the fuse back here on the main power board. And looks like the fuse is good. Now what I'm going to check is I'm going to check the regulator transistor up here, going from the case. Okay, that's okay. We have no shorts. This will tell us if the transistor is shorted without turning it on. That's interesting. So the fuse is good. Okay, we've got another fuse right here. 1.25 amp at 125 volt. That fuse is bad. That's interesting. Let's check the SCR. Ooh. I take the muffler off my car and the catalytic converters off the car to prove my manhood to everybody within a several mile radius. Let's see, it's hard to do with a frickin' tripod getting in the way. Oh yeah. No short. Okay. Wouldn't it be cool if that thing just fell apart and cooked the fuse and the thing worked? That would make happy. Okay, how did I ever live without this thing? I knew that was gonna be the case once I dumped the money and actually bought it. I'm gonna go through and check a bunch of the electrolytics on this board that usually go open. That one's there. It's not great. That one's good. Let's see. Got a big one down here. That one's good. Interesting. Maybe they were changed. Okay. Fuse. Substitute fuse with light bulb. Let's see what happens. A 200-watt light bulb. Airplane ruins ability to hear high voltage. Okay, let's try this again. Oh! Oh, oh, oh! What is that? That's like sizzling and popping. What was that smoking? Oh, well. That stinks. There's a resistor there that went crematorium. Should we short our regulator transistor now? Interesting. This was not bolted. This is not even bolted together. Someone else has already been in here. Probably condemned the flyback. Huh. That carbon resistor right there that went up in smoke, that is not original. These sets did not have carbon resistors in them. You can see the resistors cracked. So is that a missing capacitor right there? It almost looks like someone's been in here and gave up on this. And I'm starting to wonder if the condition of the CRT is worthy of restoring this electrically, especially if that flyback is bad. Check this out. I'm going to turn it on. Watch it carbon resistor turn red. Oh, you're not going to do it now for... Oh, there you go. There you go. Now we're getting her cranked up. Look at that. That's some current flow right there. See that? Oh, there's smoke from somewhere else. There's smoke from something down here too. What, this transistor? Well, that stinks. Oh, baby. That sucker's shorted. So what is that, the horizontal driver transistor in... I got the flyback totally disconnected here. And I get 0 rings. It doesn't matter what combination of leads I go to, 0 rings. Let me try and see if I can't drive some power into this thing. I ring this new old stock one out. 15 rings, it's good. Okay, I'm driving it and it's bad. Actually, it seems like it might be good because I short to the high voltage here and watch what it does. So it's almost like it's working. No spark? I don't know, it's hard to tell. Okay, I don't know if I had a bad connection here, but I hooked it back up and wiggled it around. I got 9 rings now, so taking a look at this transistor that was smoking down here. This is an NTE 315. Yeah, someone's been here before. And you know, when and where and why. We're going to do a little bit more testing here. I can unplug this, But I'm going to pull one of these wires off. They go to that big resistor right there. For some reason I don't feel like this is factory. This feels like solid core telephone wire to me connected to that resistor. That does not seem factory. I'm going to pull one of these leads off, test that transistor. I'm going to pull these leads off and test the SCR. Yeah, this thing is... I don't know what this is testing like. It's got a disc cap. Let me get that off of there. Okay, I got that thing fully disconnected, and yeah, it's bad. This should check like an NPN transistor with a gain of 1, HFE of 1. Now, it's very possible that that flyback fell apart, caused this horizontal output SCR to fail. And because this was not conducting, it caused the B plus to run away, because this regulator won't regulate unless there's somewhat of a load on it. So if that voltage ran away, then it would cause that transistor to short and fry this resistor. So I probably should have had this on a variac at about 90 volts. So I destroyed that and the resistor by not knowing that this was bad. Now these are expensive. Do I want to try and put a new one in there? I think we need to do a lot more testing. Like fix the horizontal, run it on a variac. But I think we should check the CRT first. But yeah, we need to make sure there's actually horizontal drive to this SCR before we put a new SCR in it. So this checks like a two diodes with a resistor across it. I'll disconnect that resistor now. And it appears it's good. Checks like a transistor with the resistor removed. So that's good. Alright, let's check the CRT. Yeah, I know it's getting dark out here. 6.3 volts. Let's see. Let's go to 6 volts. Okay. We'll go to cutoff. It seems like it's pretty strong. That's blue, green, red. Wow, red is really cranking. Actually, where was I supposed to set this? This is the cutoff voltage. I need to set that to D. That changed things up a little bit. That's how much negative voltage it's applying. So there's red. Okay. Green. Green is not very hot, and blue. Blue. And we'll go to emissions. That seems happy. Green seems happy. Red seems happy. Yeah, I think it's worth moving forward on, for sure. Next step, I guess, is to pull a schematic on it, and yeah, we'll move on from there. Okay, so this is using my high CRI, about a $25 chip headlamp that I made, and should be better than the daylight almost. You can see that this driver transistor has been soldered on relatively much fresher than the rest of it, so I'm going to pull that out. Okay, NTE 315. It's a 3 ohm resistor, cremated. Going through this, checking some of these electrolytics in this area, and that one right there is open, this one right here, and it actually looks like it's puked out on the board. Let me pull it off and see. I don't know if it's related or not. I just checking a bunch of them. Yeah, I don't quite know if it's puked out. It's this says 150 ohms at 2 microfarads, and it's a 4.7. These 4.7s are always toast in these sets. Like I say, I don't know if it's related. I could trace it out. It actually looks like it's connected to the base to this resistor. That was nice. Through that resistor directly to that capacitor. Like I said, we need a schematic, I think. Don't know if that would affect the whole situation. Maybe the bad capacitor fried this, which fried that, and then the transformer fell apart because it couldn't get no satisfaction. There's just a lot of what ifs here. Okay, here's our schematic. I went to the garage to get this, and I got attacked by black flies. Does that mean I shouldn't fix this TV? Very odd. Very odd. Okay, here we go. Horizontal drive. Well, there's our 4.7 capacitor that's bad. I sure hope it didn't cremate this chip. Is it possible it fried this chip? Got a 0.1 capacitor here. See how this goes through, and that's a resistor that went up in smoke, 39 ohm. And here's our SCR right here. And then I believe this thing has like 2 flybacks. So there's a horizontal out, and then over here is that flyback. This is the one here that the core was broken. This one here is that guy right there on the board. So I'd almost kind of like to put an ohm meter on this guy. And see what we got. Red to orange, we should have half an ohm. Orange to green, we should have basically a short. Red to orange. But red and orange are connected to the same spot. What? Wait, we got another orange here. Okay, this must be from here to here. Okay, well, we got exactly half an ohm there. So I think that thing's okay. I'm really starting to think that thing fell apart, fried the horizontal output transistor, and then it just kind of went from there. So I'm looking at this schematic, and I'm thinking about the transistor shorting. So the transistor shorted, and this resistor went up in smoke. This is the one that was replaced with carbon. This is the capacitor that was open. But I was looking, where would the current flow here? So we have to get enough current up through here. This capacitor will block it. So if we go this way, we have a 100 ohm, a capacitor, that'll block it. We have a 68K, that's too high, that'll block it. We have a 68 picofarad, that'll block it. So it'd have to come down through here. So how would it get to ground? Well, it would have to get to ground through the Zener diode. And it looks like the way this setup works, well, it could have possibly... No, this diode should block it here, because this diode will allow power to go this direction. So if we suddenly had 134 volts here, this should block it. But this Zener diode would not block it. this Zener diode would try and regulate that 134 volts to 13.75, and that probably wouldn't last too long. So I want to pull this Zener diode out and short it, because this power had to be flowing like this to ground. So I'm going to pull this out. Measuring the Zener diode one way with diode check, its drop is 0.471. Let's flip these around. The other way, it is 1.1 volt. Now, it should be about 0.6 one way, and then, I don't know, 13 volts the other way. So that sucker is cremated. The question is this sucker cremated? So we need a, I wonder what this is, RD15. Is that a 15 volt Zener? Wonder if that's what that is. Interesting, it says 15 volts right on the board. Yes, it is a 15 volt Zener. So I think my strategy here has to be to verify that that chip is good before I move any further. So get a Zener diode in there, and then power it up and see if we have drive coming out of the chip. Boy, that diode got so hot it burnt the board. Boy, I let the smoke out of this one. It's hard to say, but I almost feel like I kind of rolled the dice here and I lost. Because when I saw this, I thought, well, let me just put that back together and then hopefully it'll work. But apparently, as you saw when I turned it on, the light bulb started off dim, and then that transistor overheated, shorted, and got bright. Now, why that transistor failed, I don't know. Sometimes these sets do not regulate unless the whole thing works, like it's a big loop. So if you don't have the horizontal output doesn't start all the way, you don't have enough load in order for that regulator to kick in. So it's just unregulated B+, which will cause the driver transistor to short. But also we had that open capacitor in that circuit, so I don't know how much that's affecting it. Now, the next step, I need to get a 15 volt Zener diode. And note to self, do not use light bulb, use Variac and run it on the minimum voltage. So we're going to try and get a 15 volt Zener. I don't know if I have one here, if I have to go pick one up, but 15 volt Zener, and then we'll see if that chip is working. And we want to scope the signal on the base of that transistor and make sure that chip is working before. If the chip is fried, yeah, I don't know how far we go with this TV. I gotta figure that one out for myself. But yeah, I'm gonna take a break for now and go have some dinner and dig through my diode stash, and hopefully I have 15 volt Zener somewhere. Because, yeah, we definitely need that in order to go any further. I'm just sort of sitting here at 10 o'clock p.m. studying the schematic, and of course this is our supply to the chip. This is our voltage supply to the chip, that regulated by this 15 volt Zener diode, and I found some 15 volt half watt Zener diodes, which this physically size wise looks like half watt, but this number in NTE crosses to 1 watt, so I'm going to use 2 half watt in parallel. But looking at the schematic, the way this thing works is this capacitor right here is like a bump start to the system. When you power this thing up, this sends a pulse of voltage here, which this regulates. The Zener diode catches it and regulates it to 15 volts. And that starts the whole cycle, because this thing gets its voltage from here, right? Number 4, and that's what this blocking diode is for. Well, number 4 comes from the secondary of the flyback or high voltage transformer, or whatever you want to call this horizontal output transformer. This has two separate. It has a horizontal output and a flyback high voltage. But see, all you have up here is 1 and 2. So this capacitor starts the whole cycle. If this capacitor isn't here, you'll never get a pulse of voltage through here to stimulate this to start putting out the horizontal frequency and start the whole cycle. I hope I'm explaining that right, but yeah, it's what we need to do. We need to put, well, this says 13.7 volts here. But yeah, that's exactly how that works. When you turn this on, you get 100 and probably a lot more than 135 because it's not loaded. Just an initial pulse goes through here. This regulates it. The chip starts putting out the horizontal pulse, and the whole system starts running. So yeah, kind of a whatever design. But what we're going to do tomorrow, we're going to feed 13 volts into here with batteries, and we're going to look at this with a scope, and we want to make sure that this is putting out. Actually, you know what, I could be wrong there. Taking a second look here, we have the same 135 volts, so that would bias this transistor on, and then it would start conducting and it would apply voltage here. So maybe that's not what this capacitor is for. This is just a filter to filter any horizontal pulse off of the supply line to the chip. So yeah, I got to take that back. So this 68K biases this transistor on. So yeah, who knows? But we're going to power it up with batteries tomorrow and make sure that this chip is putting out wasn't damaged. So this one is actually a stray, and she's been here for a lot of years, and she's very old, and at this point she's completely deaf and mostly blind, and you can't get anywhere near her. Sad news to report, the gray and white one that's been kind of a part of the videos for a long time, he he transitioned. Wait, that has a different meaning this now, doesn't it? He passed on. Let's get that right. And he went down pretty quick, and he had some of the symptoms where he was kind of foaming at the mouth, so that was a little bit intimidating. So she still hangs around here. We're going to use batteries here to power this up. For aesthetics, we'll get rid of that. This should be about 13.5 volts, 3.3 volts per cell. I've got the scope hooked up to the output of that chip, or the base of the transistor. So I got the scope hooked up to that point right there. So we should have 7 volts peak to peak. I'm feeding basically 13 volts into right there where it says 13.75. No Zener diodes, but I don't need the 15 volt Zener diode. And thinking about it, I do think that capacitor is part of like a bump start setup. So what the hell do I know? Does it matter if we can get it to work? Here we go. I'm gonna power this up right now. I got the basically fed into that test point right there. which I believe it says 15 volts there. So here we go. Power is being applied. The Chinese clip lead has gotten very stiff. And look at that. 8.8 volts peak to peak. Wow, frequency's right on. So that looks good. So the IC was not damaged. Of course, the shape is not going to be right because we don't have the transistor in there. So this is like a power supply board, and these little, see that old gray right there, a little Motorola 1N 587B. That is a 15 volt Zener, so I'm going to take two of those out and put them in parallel because those are half watt. Wow, so I think an old friend just died. I got one of the diodes mounted there. Gonna put two of them in parallel. Actually, not so fast there. Okay, well that fixed that. Alright. No need to call the suicide hotline. I installed a tip 50 for our driver transistor. These are pretty damn robust transistors. 400 volt 1 amp. Perfect for that driver. And if you look at this sort of carefully, you can see what I did with the diode. We have a jumper there, so I just, since I didn't have the lead length, but that should definitely give me enough capacity. Analyzing my solder joints there. I was just double checking my work to make sure that I didn't have any little whiskers or shorts, and I realized I put that transistor in 180 out. Looking at it from the front, from left to right, it goes base collector emitter. I put it in, yeah, that would have been good. Okay, that looks better. Yeah, going on these TO220 package transistors, looking at it from the front, that being the front, from left to right, it goes base collector emitter. You can see how it's marked on the circuit board there. So now I got to do this capacitor. Yeah, it's, you know, I don't mind hiding my mistakes. It's easy to make mistakes, and when doing this solid state stuff, it's extra easy. So, you know, it's no problem to take a break and have something to eat and then come back and double check your work before you power it up, kind of thing. The further I go with this, the more I notice how many screws are missing. Okay, we got our new capacitor, a new electrolytic there, 4.7. I don't have a 39 fusible, so I put two 27s in there. At least we'll have fire, if nothing else. I have the SCR disconnected. I'm going to try at 80 volts on a variac and see what we get. While the capacitors are discharged, it's been sitting overnight before we do anything. I don't know if the battery's dead in this. Let's try this though. This is running the whole entire horizontal output. That looks okay. 1% efficiency. Hey. But at least we don't have a ton of current. So this is driving it just like the set would drive it. Now it's driving it at 10% of what the set drives it, but at least we don't have any blatant shorts, so that's kind of a happy thing. I have the scope connected from gate, the horizontal output gate, to ground. According to the schematic, we should have 12 volts there, 12 volt horizontal pulse. I have the meter connected from that test 15 volt test point to ground. I have 75 volts on the variac. Here we go. Oh, 1 amp fuse. And I get nothing. I guess maybe my voltage is too low for the relay to energize. Yep, nothing. There we go, it kicked in right at 80 volts. I got 14 volts, 15 volts. It's creeping up. How weird. That must be stressing the hell out of those Zener diodes. But why have I got no horizontal pulse here at the horizontal output? Interesting. So did my diodes get hot? I can't finger them. Yes, my Zener diodes did get hot. So I had 15 volts there. That's enough to run the chip. So why did I not have a horizontal pulse over here? I had a horizontal pulse going into that transistor. Now I'm on the base of the transistor. And I absolutely have a horizontal pulse going into that transistor. But why nothing coming out? We're getting 91 volts on the collector. So that transistor drives this horizontal driver transformer. Okay, what's going on here? We have a diode that the solder has been taken off of, and I did not do this. I did not desolder that, D812. So interesting, that diode that's lifted is connected to the CRT protection circuit. I don't know if that's like X-ray protection, or if the high voltage overruns, it shuts the set down, or what. But that's not what's causing us to have zero horizontal drive coming out of the horizontal drive transformer. This is very strange. I'm going to get a multiplication probe on the scope and we'll go to the collector. Maybe that transistor is bad. Okay, so we got something here. Not quite sure what to think of that. Okay, so we got something here. This is pretty small though. This is kind of interesting. So going direct, coming out of that transistor, we only got 21 volts peak to peak with a 90 volt collector voltage. That seems very low to me. And yes, those Zener diodes are getting excruciatingly hot. So what would cause that? Well, definitely excessive current draw coming through this transistor. Leaky capacitor, you know, leaky 0.1 capacitor, 68K that had dropped in value, leaky transistor. Yeah, what's going on here? I checked this voltage here, this DC voltage, and we only got 9 volts. So that doesn't appear that the transistor is being biased on too hard. So we got an overload here. So if we got an overload in this area, it'll drive extra current and raise the emitter voltage. I know I put that electrolytic in the right way. I checked it several times. But yeah, we're getting too much current driven onto the Zener diode. And we got to figure out where that's coming from. So I'm going to just start disconnecting stuff. I disconnected the secondary there, and why am I starting to get suspicious of this horizontal drive transformer being shorted? Schematic says 36 ohms, that'd be DC resistance on the primary, 1.1 ohm on the secondary. Well, we got 3.3 ohms on the primary, so 1/10 of what it should be. And on the secondary we have 2 ohms. I would take that, but obviously we could ring test this. Now the question is, did I do this when I smoked it, or was it like this? This is why there's a fusible resistor in that space where the previous person that worked on it put a carbon resistor. But we also have things like this diode disconnected, so I don't know. I don't know what to think of this set. I don't know what to think of what I fried or someone else attempted to repair. I don't know. Well, we're getting 3 rings out of this transformer. Let's try driving it like a flyback. Try driving it. AC short. So, yep, the primary, the windings all got melted together in this. I don't know. Was it me? Am I to blame? Huh. I was going to pull a horizontal drive transformer out of just a modern generic set and tack it in there just so we could look at the drive and see the difference on the voltage on the emitter across those Zener diodes and that. But I decided I'd just text a friend who has a Sony graveyard, because these are very picky. You can't just sub in any transformer there. And he just happened to have one of these sets with a CRT. So I told him I need the board. So we're going to get the whole board and just go that route. I think we were successful at diagnosing this thing. It's no longer 1977. You can't just call the parts supplier and get the drive transformer. So we'll just get the whole board. That'll eliminate this bad SCR and this disconnected diode and the not having the proper fusible resistor. I should have got the whole damn set and redone that too, but I think I got that fixed correctly. So let me get that board and we'll continue on. Here we go. So this board came out of a working set with a bad CRT. So this has the appropriate fusible resistor. It's got our working horizontal drive transformer. I'm going to check the capacitors on this real quick and we'll put it in. Well, every electrolytic on this board is completely dead. Now he said that this was a part set because the picture was all smeary and blurry like a dead CRT, but I don't think this is a dead CRT situation. I think this is it's interesting that it looks like something was plugged into that. Like maybe this is supposed to be plugged in this way. Yeah, I think this is plugged on wrong. Oh, what the? Well, let's see what happens here. I didn't change any of those caps. He said it was working. It just had a bad smeary picture. But you know, those caps can cause a bad smeary picture. You can think that horizontal noise gets into everything off that horizontal transformer, and you would think the CRT's bad. So anyway, let's see what happens. We'll go up to about 85 volts here. Oh wow, look at that. It's a little tiny miscolored. I wonder if this is what he was seeing on the other set, to where he thought that, let's see, where are we here? Color picture. Sharpness, brightness. I wonder if that's what he saw, to where he thought that the CRT was bad. Okay, also, I'm only at 85 volts. I turn this up, something starts arcing. Something here was arcing. Oh, it went into shutdown, or it fried. Try it again. Yep, died. Okay, it blew the fuse. Oh, that's it. EOL'd. Just like that. Smokeificated. Yeah, it looks like it murdered the frickin' horizontal output SCR. This is, and the capacitors are not going to cause it to do that, because it didn't do that in the set that it came out of. It fired up and worked. I got a picture of what it looked like. So, crap. So I'm gonna say the flyback's bad. I'm gonna say that transformer's bad. I've seen this before. I've struggled with this before. We need to get that whole other set here that was working. Okay, I'm gonna shelve this for now. I told him to bring me the other set that was working with the smeared picture that he thought it was a CRT, that I'm thinking it's capacitors. Unfortunately, I cremated well, now it's like $15 SCR. I guess that was a lot of money in the 80s and 90s. Now it's like the price of a candy bar. So I'm going to shelve this for now, put it together, walk away from it, and cool down, and yeah, we'll get back to it when we get the other set here. We'll make one good working one out of the two. Even if I have to take that complete chassis out of that other one and put it in here, because he didn't test that CRT, he just looked at the picture. But we're going to test the CRT. If that CRT is dead, then we put that chassis in this set. I got the other set here. This is the one that the board we fried the SCR on was pulled out of, that worked but supposedly had a bad picture tube. And so you can see them next to each other here. Dual Trinitrons for your foaming pleasure. So what I'm going to do, this is the board that came out of this set that we put in that set that originally had the bad flyback. That when I put that board in there, it fried the SCR in that board. This is the bad flyback set. This set is still got the U bolt there. So the first thing I'm going to do is I'm going to test these CRTs and compare them, because bad capacitors can look like a bad CRT, especially on solid state sets where you get horizontal noise interfering with everything and low voltages. So, and that board which came out of that set had bad capacitors. So we're going to do a comparison here. I know this gets confusing with multiple sets, but I should talk slow enough to where it shouldn't be too confusing. These are the results of the set with the broken flyback. It's the emissions. These are the results of the set that was thought to have had a bad CRT, and I would have to concur with that. And here's something: you do not rejuvenate Trinitron CRTs, period. You can see the cutoff, barely get anything. This one we get quite a bit. So on this set, the red gun is dead. Now what I'm wondering is, if I take this chassis, just take the whole, no. If I take this chassis, put this chassis on this tube, do I have to screw with the convergence? I don't think so. I think I should be able to swap chassis, and I'll swap the chassis, the high voltage transformer, pretty much the whole package. They are different. I think this is a remote set. See the extra board right there that this one does not have, and it's got that. So I'll have to, and I see a standby transformer on that one. So I'll have to look at this. These are a little bit different. But yeah, I think let me think about this. Yeah, that CRT is definitely, because these Trinitron CRTs are not just like they're not like other CRTs. They have all kinds of very special little magnets and stuff, and they're very difficult to do the convergence on. So driving the flyback with the HA325, I am seeing a different. I have them disconnected on both sets. This is the one that was broken. Come on, focus. 9 milliamps. You can look at that. 9 milliamps. I'm going to go to the other one. Okay, here's the other one. 34 milliamps. I'm not looking at good or bad. I'm just comparing. So I got pretty much everything disconnected here except this wire that goes to the CRT board and the actual connection to the CRT. I'm going to pull them both out and put them on the bench, and we'll compare them. It's weird, the one that looks the nastiest is the one that was in the working set. And yes, if this is off, it will cause the circuit to be out of tune, and it will fry that transistor. Well, I got them both out, and it's the same thing. The one that was broken is 9 milliamps, and the one that's good is 35 milliamps. And I know that really doesn't refer to anything more than just a comparison, but you can see here 35 milliamps. That's on the one from the set with the bad capacitors. And here's the other one, 9 milliamps. This is the one that had the broken bolt, the one that had the broken U-bolt. So they're definitely different, and this is very important that the tuned circuit is right. That's why it popped the transistor. Maybe I could say that like that again. How about SCR? It popped the SCR. When you assemble this, there's two connectors here. You have to make sure you get that spring in that little hole, because that spring is for the convergence. Back on our flyback that I believe is frying the transistor. I want to try replacing this U-bolt, and I actually have some of these. I found this Sony transformer, which is the same, I believe it's the same core. So what I want to do is take my wire that I put there off and try and put this U-bolt and then measure the milliamps and see if it affects it. I had another Trinitron that had one side of this broken that was also popping the transistor, and I couldn't figure that out. I ended up changing the flyback. Well, crap, I took this one apart and it's broken too. Wonder if that was a problem. This is too big. Okay, so this one is brass, so I'm able to bend this. Well, I bent the brass one and made it work. I don't know if there's a difference between brass and steel. I know there is when it comes to RF stuff. Well, it did make a little bit of a difference. It went from 9 milliamps to 14 milliamps. You know, what do you want to bet that having the right one in there would probably dial it right in? I'm not going to spend any more time on this flyback bolt thing, out of tune, fry the transistor. I'm just putting this flyback that's screwed up back in with the bad CRT. I'm not going to worry about it. This set is going to be probably just a prop. It's going to be bad flyback, bad CRT, bad horizontal drive transistor, bad horizontal output transistor. This is just going to be a collection of bad parts. It's a new day, and let's get back on the Trinitron. You know, she is extremely hungry all the time, and it's amazing how much she eats and how small and light she is. Maybe I should give her a little bit of my ivermectin and see if she has worms. Although ivermectin treats, maybe it does not treat tapeworms. It treats a bunch of other kinds of worms. Interesting. But yeah, eat up, girl, before the supply chain dries out. Cat food is getting extremely hard to get now. We know all the electrolytics in this need to be changed, and I picked them up. They're right here. We know we fried this with the other flyback. Now, according to him, this configuration, this and this were working. So, in that set with the weak CRT. So I say what we do is put this in, stick this thing in there and press the play button and see what happens. Now this is how these should check. An NPN transistor with a beta of 1. Put some new grease on this. Both sides of the mic away for another reason to wear gloves. You ever get this zinc grease on your skin? Try and get it off. I'm leaving the cathode off. We're going to monitor the current here. Our current is 1200 milliamps. Wow, that's a bit of current on this big set, but I guess it's called for, and we want to look at our monitor, the B plus, and make sure it's regulating. So 135 volts. And then probably at some point we want to come back and check this where we started, make sure it's what, 13 volts? 13, yeah, so it's not holding on to that Zener diode, it's below that. So we want to check this. So I need 1.2 amp. I gotta say, you know, as far as these Trinitrons go, I'm probably one of the last people in the USA at least fixing them. And the pucker factor right now, you know, I'd rather be jumping out of an airplane. This is monitoring the B plus. Wow, a display you can actually read. This is monitoring the current on the SCR. I have this set at about 90 volts. So $20 transistor. Here we go. Let me get to it from this side. Ooh. Oh, that was the end of that. I saw the fuse flash and no high voltage came up. I didn't even have time to see the current here. Well, we're lucky it did not pop the SCR. So what happened there? How did it pop a fuse without shorting the SCR? I got the SCR disconnected. I wonder how low I can go on this, and let's see. I can. At 75 volts on the Variac, I got 102 volts. Maybe we lost horizontal drive. Well, we have no AC on the horizontal drive. So somehow we lost horizontal drive. And that will, because these are gate off thyristors. So without horizontal drive, the output transistor is turned on. So I'm back here on the test point where those Zener diodes were, and I only got 1 volt. So the Zener diode short. It is not the Zener diodes. It's not the transistor and it's not the diodes. So what is going on here? Why do we not have any voltage on the horizontal oscillator now? Let me see if I can turbo-calculate here. Turn that on. I don't like doing this. It makes me nervous. Let's see. What do we got on the collector? We got nothing on the collector. So did that fusible resistor go open? So yeah, the 39 ohm resistor went open, the fusible resistor that we saw probably an hour ago in this video. So I just bridged it with a 68. I don't know how that went open, but let's see what we got now. We are looking at the voltage on Zener diodes. We're looking at the AC that should be stimulating the horizontal output SCR. Here we go. Well, what the? Well, that resistor wasn't so fusible. In fact, at this, no, I don't want to do that. It was glowing bright red. How? And the transistor is cold. The hell? Do we burn another transformer up here? How is that possible? That resistor right here feeds the transformer, which goes to the collector. This transistor is not shorted. I just checked it. I made a mistake. I had these two plugs reversed. Oops. That almost seems like a faulty design, that those two plugs could be flipped. You think they'd put a key or something there. Who knows what kind of damage I did. Well, we got 9 volts there and we got 11 volts AC. I'm going to bring the variac up a little bit. 10 volts. Remember, this is supposed to be 13. We got 13.5 volts AC. Okay, let's go back to where I started an hour ago. Okay, milliamps, volts. I hope I made myself clear with this SCR. This SCR is more like a horizontal output tube, where if it does not get a drive signal, it is turned on full bore, and just like a short. So here we go. I'm on B+, I'm on 200 volts, I'm on milliamps. I'm going to stay right here. Okay, 780 milliamps, 87 volts on the B+. Going to bring the B+ up. Should put these next to each other. Okay. I know we're dealing with a creeping up here. Let's take a look at the screen. We have full deflection. Well, the horizontal's a little short, but remember we got bad electrolytics here. So I'm at 100 volts on the variac. We're supposed to regulate at 135, 1.2 amps. So there's our regulation point. I'm at 110 volts on the variac. I'm at 120 volts on the variac. I'm at 125 on the variac. So we're looking good. So it was definitely the flyback. And we have full deflection now, even with the bad capacitors. And we have 1.1 amp draw on the cathode. So this is happiness. That's back down to 100 volts. So right now I'm swinging, so our regulation's working, everything's working. And measuring our driver, we are at 13.8 volts, which is right where they wanted it, below the 15 volt Zener diode. So the Zener diodes aren't even conducting right now. I know there's some blanking by the camera, but it's actually working. The red is way too high. So we got a little ringing here. I'm curious to see if when I change the capacitors, if any of this changes, because it looks good. Like I don't see, I mean, where are the bad capacitors at? And look at, we are dead on 1.2 amps. Right on the money. Okay, the board is out again. I'll try not to hook these up backwards next time. I'm going to go ahead and recap this board. We'll check the old caps. I'm going to replace the resistor, replace the fuse, steal a bunch of screws out of the other set, and hopefully get this thing put back together. This one should be 47 microfarads. This one should be 330 microfarads. This one should be 33 microfarads. Look at the ESR, 130 ohms. This one should be 4.7 microfarads. How the hell was this TV even working with all these bad capacitors? Anyway, I got a fusible resistor. I found one. It's installed. Changed all the capacitors. This is hooked back up. I think we're good here. I think I got it all back together. Here we go. Turn this on. Okay, no smoke yet. There's a lot of screws missing out of here I have to find. Got the fuse replaced. Definitely lacking in horizontal width now with the new capacitors. But we do not have that ringing with the new capacitors. Oh, I'm still on reduced voltage. Duh. Go. There we go. Now we're cooking. Look at that. That's ready to go. Excellent. No more ringing. After an hour transplanting screws, I finally got this thing buttoned back up pretty tight. So we'll watch some TV. I was taking a look at this set from the front and I just noticed the CRT is like delaminating on this. I don't know if that's going to show up in the camera, but you see that? And then look at the top here. Interesting. It's very weird. It's not. It's just like that right here.
So that your skin is healthier, so that it's firmer, it's rejuvenated, and all of the topical products you put on top are all acting on healthy skin now. They're not fighting through dead layers of skin.
And I mean, when we look at our Black Friday sale
so
price,
bright.
You're saving 50% off of our QVC price. This is usually $200. You're getting your face, your body, diamond tips. It has 3 speeds. It has a swivel head, 200 filters, tweezers, and a travel pouch.
Ooh.
$89. An easy pay of $19.80. A 4971 is your item
And it
number.
exfoliates, whatever the
2021
hell
Blue
that
Wax favorite.
means.
I do want to show you the swivel head as well. So when you're trading, you know, sometimes it is hard. A lot of devices are just kind of one direction, and you kind of have to like move your arm around to get to the right angle.
Wouldn't want to do that.
And now this, you can get the sort of angle that you need to be able to treat yourself in the best way. So think about if you know someone who's been wanting to try microdermabrasion, this would be a great gift, maybe instead of that spa appointment, because they can use this as much as they want to. If you've been wanting to try microdermabrasion, but you haven't wanted to go to the spa, this is a great gift for yourself, especially why we have this Black Friday sale price. And you can return until January 31st, 2021. So really like get in there, give this a try, and see if you see those results. Those before results. A 454971 is your item number.
Do people actually buy this stuff?
Treating herself, and now she's not having to go see Dr. Lancer. I mean, I'm sure he's sad to not see her as often, but she doesn't have to go anywhere.
Doesn't have to. And you know, like most people, who has the time, especially when we're wearing masks right now too? Our skin's getting full of dehydration and gunk, and who wants that unhealthy skin? So the
Well, then don't wear a damn mask.
Tool that is so easy to use.
Jeez.
And Vanessa, I just have to show you. It's disgusting, but I have to show you. That is from one application, the lint tray of this device. Ew is right.
I don't call that disgusting, Devin. I feel like that's really oddly satisfying, because I'm like, now it's not in there anymore.
I just want to take my hands and just keep, you know, brushing them against how smooth my skin, especially into the.
I'm using a converter box.
Your lips, when they're dry and chapped, put it
over the air,
right over them.
Yeah.
Over the air broadcasts of microdermabrasion.
Saving you 50%.
Exfoliates. Got to be careful.
The guesswork out of preparing your proteins and anything that you put on it. It gives me the ultimate level.
That we would use rehydration to process our dish. It took a lot of preparation because
the ultimate exfoliation. Ooh, that's in 4x3. That's definitely exfoliating.
For all of your stones. Beautiful under gallery, total cocktail ring without being
under
like
gallery.
Too much. It's a lot. I mean, that's
under.
That's
what
a
is?
big,
let me adjust the
glitzy,
tint here.
Glamorous ring, but I don't think it's too much.
Oh, there
it's
we
not
go.
like one of these way over the top.
Under gallery.
That is an empowering, strong, beautiful force to be reckoned with.
Oh,
in
yes.
a lot of stone. Over 5.1.
That's a lot of stone. That's a force to be reckoned with.
$59.99. I think this is a sellout at that price. We have a
exfoliating. All right, that's enough. It's definitely
that value
working very nice. Has a very nice, stable, clear picture. Look at that.
Full holiday return policy that ensures you have so much time to wear this, to love it. If it is a gift, she's gonna have even the full month trial period.
Because she got rocks up on them fingers.
During one of your nights of Hanukkah.
Oh yes. She got rocks up in her.
God, I mean, just looking at it makes you think back.
90 days. Risk.
All right, well.
Pores and wrinkles and can make your skin look rough. But with Breeze, you can go from this to this. The secret is how our premium foundations blend onto the skin with an ultra-fine mist using the power of air. Very.
All right.
The eye area there, how dry it is, the crow's feet on the end, the lines that extend down onto the cheek, actually, the dark shadows, and then look above the eyelid there. It's drooping. It's dry. There's crepey on the inside too. It looks like there's some
Ooh,
cross hatches and some
crepey.
dryness. But after 4 weeks, this model used the 3D eye serum twice a day, morning and night. And look at how much lifted the upper eye area is. I mean, that upper drooping eyelid is just so much firmer and it's lifted up, giving her a widened look. An awakened look.
Awakened, yes.
Awakened, a widened look. What is an awakened look? I don't know. It has an awakened look, and I need to be awake. And then the crow's feet. This has caffeine. What does caffeine do? It wakes us up, and that's what 3D Eye is doing. It has 3 different sizes of hyaluronic acid.
Jeez, if people really think like this, no wonder why the country's going to